Hello there, this is Michael Field, and I'm recording a video to show you what I've been working on. As you can see, I have my maze class here. Let's do the other Java split stuff. Those are just projects I used as reference points for this. So what exactly did I do? Well, I have a maze. And this is my maze class, as you can see. There's a lot of code. A lot of code I actually edited out. Like as you can see here, I have a lot of system.out.println statements I use for testing things. Here's my display method. I guess I'll add a little bit of notes. Like, the display method is like one of the three things that we needed because it actually visually rises everything up. I'll exploit everything in time. But the important thing is I have a representation of like a maze in ones and zeros, for which I am very happy with. And some of these methods I didn't even use. I didn't even use makePathX. Like, at random run, I actually forgot I had that one. I ended up using another one. But it doesn't matter because my code's ultimately fine. My main methods at Common Program is mainly used to test this kind of thing. As you can see, there's the string that I use. I mainly stuck to the main one, which gives you a 4x4 cell. I actually converted from cell to like just raw numbers, ones and zeros, because it occurred to me that would be like an easier way of doing the problem. Because I wasn't really familiar with how cells work, and I have to make a cell class with all the walls and properties, and I figured an easier way would just be to take a 4x4 cell, find out that there's 9 numbers in there, so make a 9 by 9 matrix representation, which I actually do. I do that in my hold on a second. I do that in my constructor here. So I do this dot width equals 3 plus 2 times x minus 1, which is pretty much how I figure out how big the array needs to be. And that's my constructor. And it takes I have a lot of fields too. So I guess I should be using this to talk about like what I did and what I learned and like what I'm proud of. This assignment took me, I'd say, a good like at least 14 hours or something, because I finished like the first like 5 methods in like 5 hours or something. Those weren't the hard part. The hard part was part 6, because I tried a bunch of things. And it wasn't until today which I had a realization about how to fix it, so to speak. And what I did for the solve method, I think that's the most important one, because it involves traversing through the maze. And that to me is pretty important because, I mean, in an actual game, you need to know how to get through mazes and stuff, and optimal ways of doing so. So, the algorithm I used, I looked it up. One called recursive, I think it's like recursive backwards tracer, or something along those lines. But what it does is it goes through the array, and it basically lets you, oh no, it goes through my maze, and it tells every time it goes north of a can it goes east, if a can it goes south, if a can it goes west. And every time it goes somewhere, it leaves a V to let it know that it's been there. If it runs out of places, it goes backwards, and it keeps going backwards until it finds a new square to go to. And doing this method, I will always be able to trace something to it. And that's the formula I use. And in order to do that, I had to use stacks, as you can see. That's like my else if statement here. Like, not there. I put every time I like every time I I basically activate it, I move something to the top of the stack. And every time I run out of places to go, I remove that from the stack and make that my item. So that's pretty good stuff. I think it works pretty well, and I'm pretty happy with that. And so trace is cool. Trace works for the most part. And no, not trace. I get solve and trace confused. Trace is also really just all I did was take the solve method and had a bunch of print statements for the trace path, which I recorded. The next thing was the hard one, because that was the 6 method now. Or, yeah, which would be remaking the maze. So, in order to do this, I had to think a bit about how I wanted to approach it, because I think all the websites I went to said to approach it like using cells, but it didn't seem practical to me because I wasn't using cells. I wanted to use my own means of solving the problem because it means more to me that way. So I thought about it, and I realized that I thought, well, first of all, I made my own modification. I didn't like how the maze was closed, so I wanted the maze to be open somewhere along the border. So what I do is I randomly pick 2 places along the border to be my opening, my open coordinate and my beginning coordinate and my ending coordinate. And I actually use my solve method, which returns true or false, the Boolean, remember, to check if I can successfully navigate through the maze. And it took me a while to get that to work. Like, I had to constantly, I found out that my solve wasn't always returning true or false when it needed to be. I had to do a lot of debugging that way. I also had to do like a lot of testing with the border stuff, and for a while I kept going out of bounds and stuff because I was starting in a wall, but eventually I found a ways to get around that problem. For instance, for solve, I say I have an if statement that says if beginning x equals width minus 1, which is basically saying avoid those end spots because they can give you array out of bounds exceptions. So that works pretty well. And I have a set method which clears everything and basically fills the whole grid with zeros. And it actually creates something called the border, which is all the stuff on the border, more or less. And I have a method for picking the starting point to set the starting point and the ending point too. And I have a method called change inner maze, which actually calls for set pick starting point and pick ending point, and loops through it. And there's a 50% chance that I use a random choice, and it can either turn out to be a wall or it can turn out to be clear. And depending on that, determines the outcome of the maze. Now I use this change inner maze, and I use it in redesign, which is the 6th method that we required to use. And well, that's awesome things. I call it there, display it just to check it. Then this is all checking stuff here. I then have I make that a boolean whether it comes true or false, and depending on if it's false, I call it again. So I keep going until I find one that works. Is basically I'll find a working maze from the beginning random point I select to the ending random point. Now this may not be the optimal method because there are times when I run it that the maze I get isn't actually like very far. It's like the 2 points it picks are right next to each other along the border. Oh, and there's another thing I had to fix, which was basically like every time I use the solve method, I use the V to let me know where I'm going. So I switch to that, and it won't go because it only looks for zeros. V fixer basically goes through the maze and replaces V with zero again. So I guess you want to see this bad boy in action, right? So here we go. That's the wrong. Well, that's the website. Is where I'm recording this, but I mean, I'll give you 15 minutes. So I'm gonna be fast. Here it is. Here's the string manager for casting. Okay, so a lot just happened there. I get this far as my way of testing things. I build the maze. I return true, and as you can see, it goes from 1-1 to 7-7. Goes all the way to the end. Which is pretty cool. It gets here, which is really nice. And then I generate a new. I reset the maze. Get 2 new points, as you can see. Stick in this one and that one. And seeing if we can do it 2, 8, and it's going through again. It's returning false, so it was unable to like get to the end there. Which is weird, because it totally should, but whatever, it's probably like another glitch or something. Yes, maybe I'm not running it yet. Now I randomize it, and I get a whole bunch of 1s and 0s. And then I test whether it works. And it doesn't work. That one doesn't work, that one doesn't work, that one doesn't work, that one doesn't work. Eventually I get one, like I said, where the 2 zeros are next to each other and therefore it works. So I could go back and make it so that this doesn't happen again. But I think it works for the most part. Yeah. So as you can see, this one works. It goes down here and to the left. So it's pretty cool. I had a lot of fun with this assignment. It really challenged me, which is something I really like, and I like the whole concept of mazes, because I like the game Minecraft, and that's like all about this. Actually, that was the idea of the algorithm I got. I got it from like digging tunnels in Minecraft, and I'm like, how would I best approach getting from one point to another? Something to think about. So, anyways, I look forward to class tomorrow. This is Michael Field signing off with my homework presentation. Thank you.